This video is to help you with your Chapter 14 of your Sirkin textbook. Please turn to page 504. What we're dealing with here, what we're going to explain, is additional aspects of correlation and regression analysis, the statistical significance for R and B. Notice my table is different than one in the textbook. It's the same data. I like to put my x and my x squared column side by side, my y squared column next to each other, and then my xy. And then on the far left, what I did is I put the y prime, pretend that that's drawn correctly, the prime symbol. And remember, this is very similar to when you did y hat as far as the processes you go through and the steps you take to figure it out. It's very similar to the chapter 13 of your Sirkin textbook. So let's go back to this, the x data. Again, the tables, you have your data, you have your n, which is 6, because we have 6 scores. We have 6 scores for both the x and the y. It's 1, 2, 3, 4, 5, 6 for both of them. So let's look at our x. We have 1, 2, 3, 1, 2, 3. You add that up, summation, you add those together equals 12, and then I figure out my mean right away. So it's 12 divided by the total number of scores in that, which are 6, which equals 2. And then go to my x squared, which is 1 times 1 equals 1, 2 times 2 equals 4, 3 times 3 equals 9, 1 times 1 equals 1, 2 times 2 equals 4, 3 times 3 equals 9, add all those together, that's your summation x squared, 28. Next column y, we have 1, 2, 3, 3, 4, 5, summation y equals 18. Again, I take the mean of that, 18 divided by the total number of y's, the data, which is 6 again, so 18 divided by 6 equals 3. So then, I square it, 1 times 1 equals 1, 2 times 2 equals 4, 3 times 3 equals 9, 3 times 3 equals 9, 4 times 4 equals 16, 5 times 5 equals 25. As you know, some previous ones, I actually show that in parentheses, I put 1 times 1 equals 1 for these, but to fit it all on the same board, I didn't show the math in my blocks here. But it's good to show you math for the professor. XY, that's 1 times 1 equals 1, 2 times 2 equals 4, 3 times 3 equals 9, 1 times 3 equals 3, 2 times 4 equals 8, 3 times 5 equals 15. Again, for space, I didn't show my my work because of the size of the board, but again, when you draw it for the professor, what you want to show them is, you know what, they can see what numbers you multiply by each other to get it. So there's 1 times 1 equals 1. And for the next one, it would have been 2 times 2 equals 4. I would have shown it on there. Pretend you can read that correctly. 2 times 2 equals 4. So you show that to them when you write it up. Again, we sum this column, all the summation of x times y equals 40. Now we go to our formula. R equals, yes. R equals, notice I put parentheses again like my other videos. The textbook doesn't put these parenthesis marks in between, but I like to do that so I can clearly see the different numbers and then multiply them by each other. Because when we put the numbers in it, it can get kind of confusing when you look at it. So, n times summation xy by subtract by summation x times summation y. This is on top of or divided by the square root of n times summation x squared minus summation x. Then it gets squared. When we figure out that stuff, it's going to be multiplied by n times summation y squared minus summation y, and then it gets squared. Now, if you have to memorize this formula, not that this is mathematically correct, scientifically correct the way I'm going to explain it, but the way I like to do it when I memorize it is r equals n times summation xy. The first one, and that's subtracted by, they like to be fair, so then you got to multiply the summation x by the summation y. Again, there's not validity to this, when you figure it necessarily, but it's an easy way for me to memorize it. And it's n times summation x squared. Well, that wants to be subtracted by summation x, then you have to square it, because it also wants to be squared like that one was. And similar to here, it's n times summation y, it's squared, and you subtract it by summation y, and again, it wants to be squared. The other one was squared ahead of time, so it's going to be squared after again. That's not like mathematical, but that was a way I could memorize it. So now we plug in the numbers. N equals 6, as we know from before. There's 6 in both the x and the y, 6 status. There's 6 there. So it's 6 times summation x squared times y, summation x times y, which is 40, summation x times y. And that's subtracted by summation x, 12 times summation y, 18. And that's on top of n, 6 times summation x squared, 28. Subtract by summation, the sum of x, which is 12, and that'll get squared after the fact. That is multiplied by n times summation y squared, 64, minus summation y, 18, and then it will get squared. So what we're going to do first, let's move over here. We're going to go 6 times 40. 6 times 40 equals 240. 12 times 18 equals 216. Then on the bottom, what we're going to do is 6 times 28 equals 168, and then 12 times 12 equals 144. Then we go over to the right here. We take care of the y stuff, the n and summation y squared. So it's 6 times 64 equals 384, and then you have summation y, which is 18 squared equals 324. So we show all of our work there. That way if we trip up and we make a mathematical error for the class we're in, ladies and gentlemen, we'll look at as far as if you understand the concepts of it, and if you can prove you understand where all the numbers come from and how they work, that is viewed, because it's about the analysis, if you understand what this means for our course. R equals, then we go 240 minus 216, 24, divided by the square root of, first we go 168 minus 144, 20, which equals 24, and 384 minus 324 equals 60. Then we show our next step. Yes, we show we can multiply. 24 times 60 equals 1,440. That's over 24. So now we got to take care of that square root thing. What times what equals 1,440? So that's 24 divided by 37.947. Now we take care of the division. 0.63246. Then it equals, notice I put a 0 in there. Sirkin doesn't have a 0. I like the 0 before the decimal place. Yeah, I like that there, so I can see it in the decimal place better. 0.623. So then when you figure out r squared, what you really got to do, you got to keep all the numbers out. It makes a difference of what your final answer is. So what you use is the non-rounded number, not the rounded number, for when you figure out r squared. So it's 0.6324446, and that gets squared, so that's 0.40. Now what we do is we figure out our b. This again is similar to the previous chapter, and what you can do is, Sirkin doesn't show it out, because if you notice there's a similarity, notice the n times summation x, y minus summation x, summation y. Notice that's similar to our top for our r. And what we have underneath here, the n summation x squared minus summation x then squared. Notice that's similar to the left side there, but of course it doesn't have the square root sign, and we're not multiplying it by this other stuff on the right. But it's similar. I showed the math again. I recalculated it. That way if I realize if this looks different than the previous one, I have a problem. I had a mathematical error. So we put our n in, which is 6, times summation xy, which is 40, minus summation x, the sum of x, which is 12, times the sum of y, which is 18, over n, which is 6, times summation x squared, which is 28, minus summation x, which is 12, over there, and then it gets squared. So again, we show all of our steps. 6 times 40 equals 240, minus 12 times 18 equals 216. 6 times 28 equals 168, and 12 times 12 equals 144. Then we go, our next step, we subtract. We show that we know how to subtract. So it's 240 minus 216 equals 24. 168 minus 144 equals 24. 24 divided by 24 equals 1.0. There's a point there. It's faint. Again, there's a decimal point. So now that we figured out the B, now we figure out the A. Yeah. So A equals summation Y minus B. Notice I have my brackets again, my parentheses. This way, when I put my numbers in stuff, I know I'm multiplying. It's easy to see the numbers where they're separated too. So B times summation X over N. We know our N the whole time it's been 6, our N is 6, but let's work from the top. Summation Y, 18, minus B, we know B, it's 1.0, it's 1, times summation X, which is 12. So again, we show our steps. 1 times 12, we show that first as 12, so it's 18 minus 12 over 6. And then we show 12, 18 take away 12 equals 6, and that's over 6, that equals 1.0. So now we have what we need to figure out our y prime, which is y, or y prime here, equals b times x plus a. Notice again I have my parentheses. I like my parentheses. I can see the numbers better. Again, I put my little prime symbol there, which in the book I think they just had a y. Because I'm going to show you, I'm going to fill out that thing on the left there, the left column. So it's y equals 1.0 times x plus 1.0. Now this, what I call a thing, this column is very important. Well, what this is the y prime. This is saying, if we take that x, and if we use all this information we got, what would we estimate our y to be? So, I like to put it here. In this, I made the column large enough, and I showed all of my math, which I would be doing for all of them if I was submitting this. Y equals 1.0, that's submitting it to my professor. 1.0 times 1 plus 1 equals 2. And again, I'd say 1 times 1, then I put 1 plus 1 equals 2. So 1.0 times 2 plus 1 equals 3. 1 times 3 equals 3, if I would have drawn out more, plus 1 equals 4. 1 times 1 equals 1. Plus 1 equals 2, 1 times 2 equals 2, plus 1 equals 3, 1 times 3 equals 3, plus 1, pretend that looks like a 3, equals 4. So now that we have this, what we're going to go over to is part 2 to explain Sirkin. Page 504 and page 505. Okay? So going to the next video after this one, I'll explain the second part of this.